AI-assisted development with Michael Perry.
The AI DevOps podcast is a show for those shipping software using AI, .NET, Azure, and DevOps. Each show brings you hard-hitting interviews with industry experts, innovating better methods and sharing success stories. Sponsoring the podcast is ClearMeasure, a software architecture and engineering firm that implements AI to empower software teams to establish quality, achieve stability, and increase speed. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that AI, Azure, and the .NET ecosystem has to offer. My guest today on the show is Michael Perry, and he's a director at Improving Enterprises and a self-described software mathematician. And he spent his career applying mathematical principles to software development, drawing on the foundational work of thinkers like Bertrand Meyer, James Rumbaugh, and Donald Knuth. And he's the author of The Art of Immutable Architecture. And he's also the creator and maintainer of Jinaga, an open source immutable runtime framework for building collaborative and distributed applications in .NET and JavaScript. He's received the Microsoft MVP award for over 7 years, and he's produced multiple Pluralsight courses covering CQRS, XAML Patterns, Cryptography, Provable Code, and much more. And he's a frequent speaker at developer conferences across the country. At Improving, he helps enterprise clients harness the power of immutable architecture and software mathematics to build scalable and robust systems. Michael, welcome to the show. How are you, sir?
Thanks, Jeffrey. Yeah, doing wonderful. Glad to be here.
Awesome. I'm glad to get you on the show as well. We've been talking about AI quite a bit in our architect forums that you've participated in. I want to kind of ask you about your experience because you're teaching this, and I want to ask you about your course. But before we get into that, I always like to ask the guest a little bit about your background. You've been in the software engineering world for multiple decades now. And what is it about computer programming and software engineering that just keeps you excited for tomorrow?
Yeah. I always think of this one specific moment that occurred early in my career. I was working in an oil and gas company in an office right next door to an engineer, and I was rewriting their application. They hired me on because I was a Windows expert. I knew C++. I knew the Microsoft Foundation classes, if you remember that.
Nice.
And so the engineer comes over to my office and says, "Hey, I'd like you to help me with something." I go over to his office. I see that the application is up, and he's got a well-bore graph on the app. And I say, "Oh, it looks like you're testing the app." And he said, "No, I'm using this for real work. Even though it's not complete, it works better than the app that we're replacing. So I prefer this one." So after that, I forgot everything that he said. I was just completely hooked on the fact that the work that we do help others to have a greater impact.
Wow. I didn't quite become an expert in ++ or MFC, but so many technologies have come and gone since then. And it seems like the technology continues to change, but the problems largely stay the same, or at least they rhyme.
Yeah, it is kind of funny, especially now with AI changing things so rapidly. It's easy to feel overwhelmed, but if you take a step back and you think about first principles, you think about the mathematics behind it all, you think about common patterns, you can usually find something from your past that you can apply to what you're trying to learn right now, and that helps to really unlock things, especially as a mathematician. Patterns are all that there is.
Yeah. Well, let's get past the fear and the wringing of hands regarding AI, because you're not slowing down anytime soon, and you're not hanging up your career because AI is putting you out of work and all the hype there. So what is your take on artificial intelligence, and what's your, have you completely got past the hype and fear cycle of AI is going to do all of this, or it's going to do, and what's your take?
Yeah, I do feel it. I do still see myself giving into the hype a little bit, maybe feeling a little bit of dread some days. But I always come back to ground zero, where I recognize that a job is a series of tasks, and some of those tasks are things that we can offload to automation. Even before AI, some things were very easily automatable, but now with AI, just more things are. But there are other tasks within our jobs that are not automatable. These are the high value tasks. These are the things that are all about relationships, working with other people. These are the things like building trust. These are the things that require our taste and our discernment, that only we know what is best for us. And then as we build those relationships with other people, then we can now be their champions, and we can apply our taste and discernment to identify what's best for them. And that is something that we bring to the collaboration with humans and machines, so that as we put AI to work for us, doing those automatable, compressible tasks, we can now apply our own eye toward what is good and really impose that upon the machine in order to get much better outcomes.
Right. I've had a young person who elected computer science and just started schooling, asked me, just point blank, is there going to be work for me? Did I choose the right field? And a lot of what you just said, it's like, you know what? There are problems that are so unique in different businesses, and they're going to be shades of gray different. But we have, ever since computers were invented, we've been figuring out how to get them to do interesting things.
Mm-hmm.
This really doesn't change that pursuit. We're still trying to figure out how to get computers to do interesting things.
Yeah. And I've heard people ask, is now a good time to enter computer science or programming? And there's never been a better time than right now. The tools that you've got available to you to learn to build something that you could just imagine yesterday and now it exists today. That's incredible. Come on.
I would love to be 18 years old right now.
Yeah.
I'd love to be 16 years old. But I mean, just Michael, you remember how many hours you spent banging your head against the computer just to try to get one function to work of something weird. And now it's like, oh man, we can go so much faster.
Yeah, I know it. Yeah, and you just but you still take all of the experience that you've gained over those years, all of that, all those scars of banging your head against something and figuring out what doesn't work, what does work. And then if you impose those opinions upon the machine, then you'll get a result that is not just the average of what it was trained on, but you'll narrow in on that part of its training set that is more specific to what you were really after. So yeah, it's great for people coming on board. It's also great for the people who have a lot of experience that they can now pump back into the AI. So somebody with a lot of experience is going to be able to get much better outcomes than somebody who comes in fresh. Mm-hmm. However, they're both going to be able to get the job done, and that's wonderful.
Right. Well, you have an online training course on the topic of AI-assisted development. What's all that about, and what prompted you to say, you know what, I'm going to make a course on this?
Yeah. So that's on Pluralsight. That's my most recent Pluralsight course. And I had been using AI-assisted development tools since the beta of GitHub Copilot. And it was in beta for a full year. I think from 2021 to 2022. I might have the dates wrong, but I remember that when they said, okay, it's going to be out of beta, we're going to have to start charging money. It's like, here you go, take my money. This is so valuable. And at that time, it was really just completions, and not even getting the right things, right completions every time. But since then, it just grew. So I started to adopt Ru code, and then with the release of Claude 3.7, I think it was, Sonnet 3.7, I've noticed it just really increased. And so I really started to dive into it then, and got into Claude Code and tried several different other tools, Cursor, just learned them all. What's different, what's the same, what are those patterns that I should look for? Mm-hmm. And so when Pluralsight was starting to put together their learning path for AI assisted development, I was like, that I need to be a part of that. That is what I've been working on. I've got a framework now that works for me. Let me share that with other people.
Yeah. RuCode, you mentioned, what is that?
Yeah, RuCode is an open source plugin for Visual Studio Code, and it was the first one, and it's ROO as in kangaroo. It's all Australian themed, but it was the first one to have what we would now call subagents. They called them Ru modes. And so just like when you can pop open, go from chat to ask to plan, all those different modes. With Ru, that was the first one that you could create custom modes. And then you describe, okay, this is going to be my TDD test writer mode, and here's my TDD test code writer mode that makes the test pass. And then it offered these things called boomerang tasks. I was trying to remember the name. It's all Australian themed. Boomerang tasks allowed you to say, okay, I want to test drive this feature. And so it says, oh, I see that you've got a TDD test writer. I'll go into that one, brand new context, fresh window for it to work in. It writes one test, and then it just reports back, I wrote this one test, and you don't see any of that context pollution of everything that happened while it was doing that. And then, the orchestrator says, okay, now I'll go to the code writer, and then I'll go back and it'll implement the whole TDD workflow. And so, boomerang tasks were the time that I said, okay, this is really serious. We can build a machine out of these parts.
That's interesting that you bring up test-driven development because I think, our whole industry, we're trying to figure out which processes, large and small, are appropriate, even if we delegate big swaths of it to the machine and have AI do it, and which processes that we have adopted over time are less relevant if you're just having a machine do it. And so just take test-driven development. What have you learned on that? Do you still have your AI tool make a test that fails first and then make it pass, and then rinse and repeat and do it one at a time versus, authoring like 10 or 15 at once? What's your take on that?
Yeah, I think it's incredibly important with these machines to close the loop. That if they produce code and say, here it is, then they haven't closed the loop. They haven't validated that code. If they produce it and then run the linter and then run the compiler, okay, they've gotten a little bit better at validating it, but that's still a linear process. You really need to bring it back to the beginning and close that loop. And so they need to be able to see the results of the code that they wrote. And there are two ways that I've found that are really effective to do that with LLMs. One of them is test-driven development. So I need you to implement this feature, write the tests that describe the behavior of the feature, then write the code, run the tests. It'll close that loop. It'll say, oh, I got that right, or I got it wrong. And when it sees that it got it wrong, it knows exactly how to iterate. You can go back through, make those changes, and see if it got back on the right path. The second way that I've seen to do that is to give it access to the actual user interface. So you can use Playwright MCP to do that. You can use, if you're on a Mac, you can use the automation tools that are built into to the Mac. And you can actually tell it to drive the application, take over the mouse, take screenshots, and drive an application, and then use that to close the loop. Watch it iterate back over itself and say, oh, I got that wrong. Let me change this. Let me run it again. So yeah, I think practices like test-driven development are even more important now that we've got these machines.
So from a literal perspective, you have the tools doing red, and then green, and then refactor, and then test number 2, red and green and refactor. What's literally the sequence?
Yeah, so literally I actually have 5 agents. So the first one is the most important step, and that's plan. So that takes a problem, it breaks it down into these are the tests that are just going to set up structure. And then these are the tests that are the happy path. These are the tests for edge cases, and then these are the tests for all the error conditions. So it's going to then write all the tests that it wants to run, put that into a markdown file, and then it's going to go to the red phase. Now I have noticed that these tools do like to write a handful of tests at the same time. Even though my instructions say one test at a time, it still says, well, I need these 3 data structures, so let me go ahead and write 3 tests. And I've not seen the quality degrade because of that, so I allow that to happen. But if it were to write all of the tests first, then it wouldn't be able to learn from the earlier tests about what the later tests really should be. And so I do like to constrain it and make sure that it at least writes a small number of tests through each phase. So that's plan, test, then the plan red, green. Then the other two are two different refactor agents, one for refactoring code and another one for refactoring tests, because those two refactorings have different goals in mind. So I like to refactor my tests to read a bit more like BDD. So more of a given when then style of writing an invest style test. And so then the other important part of that is that these agents are told to escalate if they run into any issues. So it has written a test. You're now in green, and green finds that I have to create this data structure in order to complete this test, but that wasn't supposed to be part of this test. And so it's got special instructions, escalate under these conditions, stop what you're doing and escalate it back to the orchestrator. And that really helps the orchestrator to now learn from what it's done on a previous iteration to correct for a later iteration. So yeah, that's kind of the shape that I like to put everything into.
Okay. Now, listen, it seems like in so many projects, the writing of the code that can be validated by unit tests takes a small amount of time.
Mm.
And then integration with other systems that you connect to takes a whole bunch of time. Have you found any good techniques for getting AI to have the ability to test the loop all the way through other systems that include all the integration problems?
Yeah, in order to get there, you really do have to invest in building a good scaffold. That part is no different. I guess the latest innovation that really helps there is Docker. I still do remember the days before Docker, and that was really hard to do back then. But now with Docker Compose, you can have one YAML file that says, I want this service, this service, this service. They're all connected in this way. And so making Docker Compose up part of that loop has really helped me in that regard. So that means that this loop now takes a lot longer. It has to compile everything, Docker Compose up, and then migrate all the databases, run all the tests, come back through. But it's patient. It can do that. So yeah, run it through a faster TDD loop before you do that. And then, yeah, you can really test your systems end to end.
Nice. So I want to ask you about what you found with actual teams at the macro level. So we've talked about something that you might do individually and how you might individually operate some AI tools. What about larger teams like 5 or 10 people? Have you found, has the dust settled for you on any practices where you would say, okay, whole team, do it this way. This way works. We've seen it, because a lot of other things we're still trying to figure it out. But has the dust settled for you on any things that elevate where you say, this is a good team practice now?
Yeah, I would say that one thing that has really, really settled out for me was to construct a software factory. And so you gave a great demo of a software factory, and I'm working on a framework for how to talk about software factories. That's at factoryengineering. But it's now the team's responsibility to build the software factory, not to build the software. And so that means that the team is putting together the skills that capture their team norms and their opinions about how the software should be. They're putting together the agents. They're putting together the workflows. And then they are observing that factory working and then modifying the factory as they go along. And so I consider that a team skill, because now you are elevating the team to to a higher level where they're now working on a higher level abstraction over the system. So I'll tell you a story about how I applied software factories to a team that they were brand new to AI. So I knew that we had a whole bunch of stories in the backlog that all looked very similar. And so I sat down with, we were using Cursor. I sat down with Cursor and said, go ahead and review all of these SQL scripts because we've got a lot more to do. Tell me the patterns that you see here. And it basically learned over the year and a half worth of work that this team had already put into this project what a good SQL script looked like. And so I said, okay, make me a skill that captures all those opinions. I mean, that's literally all that I typed. And then it generated this big old skill with lots of resources and all sorts of fun stuff. And then I said, okay, take a look at one of these user stories. Now, see if you can steel man this user story. See if you can take this somewhat vague human description and turn it into a rigorous, here's the mathematician coming out, description of the problem. And then, okay, it wrote the user story. Write me a skill that describes those user stories. And then I said, okay, now we're going to take this user story, we're going to turn it into that script, do that once, and then create a command that follows exactly those steps. So then I delivered to my team, first of all, got them all Cursor licenses. So, okay, let's get in a room, open up Cursor for the first time. You're first logged in. Now I want you to type in /write script at user story 123. That's it. I don't want to teach you prompt engineering. I don't want to teach you how to interact with this thing. Just type /command at artifact and hit enter. And then watch the command use those skills in order to create this code. And then, because these were the people that had written those scripts in the past, they were able to look at the output and see, oh, this looks very similar to what we've done before. Yes, it was trained on exactly what you did. Now it's up to you to use your taste and discernment to verify that the script is good. Go ahead and test it the same way you had before. Create that PR, review the PR. All of those things starting off were still the same, but giving them the command and the skills to just have that baseline of that software factory allowed them to compress the time that it took them to deliver a story from 5 days down to 1 day per story.
Nice.
And so that got us through that huge backlog and got them the first taste of AI assisted development.
Very cool. Very cool. Now I can hear a listener screaming out a question right now. They're saying, okay, got it. You can do things that you've done 100 times before. We can get AI to do it. But I thought I heard you, Michael Perry, say that we're gonna design and build the software factory and not the actual software. But wait a minute, what if I haven't built this type of software before?
Yeah, that is a different pattern. So yeah, the pattern that is just described is your brownfield application pattern, which, to be quite honest, where we are right now, that's the one you're going to be using most often.
Yeah, it's a ton of work out there.
Yeah. But yeah, for the greenfield, the way that I've approached that is I sit down and I say, here's kind of a high level of what I want to build. These are the constraints on the system. So I need this to be a web application or a mobile application. I need this to serve, I need to have decent uptime, or I need to be Netflix scale, whatever those constraints are. Now tell me go ahead and do that research. You have to tell it to do the research. Otherwise it'll just serve it from its general training. No, search the web, find some alternative stacks for this thing that I want to build. And I always like to leave it open how many alternatives it comes back with. Some people say, give me 3 alternatives, give me 7 alternatives. I like to not give a number. That way it can come back with, it's never come back with too few in my experience. So yeah, leave that open. Then now you review those alternatives and then you might start doing a little bit of research, figuring out some new stacks yourself. And then you've kind of primed the pump. You've filled the bucket, as I like to say. You've filled its context with a lot of useful stuff. And then you can ask it to generate just a high-level architectural document for this chosen stack and iterate on that. Then say, okay, I see that React is part of the stack that we chose. I already have some opinions on React. Maybe I don't know about these other parts of the stack. So I'm going to tell you about my opinions about React, and let's create some skills that codify my opinions. So put all of this into place, get several skills in there, get several markdown documents in there, and then you can create a plan for scaffolding the project. It sounds like this is a long process. What I'm talking about here is a really fun hour and a half of time. So yeah, you can iterate in order to create a brand new place for your application to live.
Okay, so you said get some specs in here, get some docs in here. When you say in here, are you talking about the Git repository?
Yes.
Or what are you talking?
Yeah, definitely in the Git repository. I think that eventually something else will come to replace the repository or augment the repository with additional memory. Right now, we can hook up MCP servers, for example, and say, okay, this is my Jira MCP server, my Azure Devops MCP server. And so part of the solution lives out there and then is brought in through the MCP server. Although I feel that right now it's still best to have the artifacts and the factory components like the skills and the code all living within the repository and all versioned consistently. Yeah, that might not be true for very long, but I think that's true right now.
All right, just a few tactical questions. Saying this term skills, is it anything more than just a helper prompt?
Oh, yes. Yeah, skills are so much more. So yeah, this is the agent skills standard. This is a standard that Anthropic created probably around February, maybe January. So, I mean, it's a really, really young specification, but it is
It's
already
months old.
taken off. But yeah, skills, in addition to what you would think of as a markdown file of things that should be loaded into context, but also it's a set of links to additional resources so that the LLM doesn't have to load the entire book. It can just load the table of contents and then read just the first paragraph of the header of the chapter that it needs, and then just read the one section that it needs. So that really allows you to manage your context well. And then in addition to that, you can also have scripts in there. So Python scripts, Bash scripts, PowerShell scripts, so that your skills now have teeth that can do something. So yeah, I'm constantly iterating with the LLM. So we go through a task together. Like I have a skill that I use to access Azure Devops. Rather than using the MCP servers that are already available, I actually have a skill instead that uses the API and a PAT in order to access it. So because I don't need to do everything with Azure DevOps, that surface area is huge. I need to do a small set of things that are focused to how my team works. And so when I run into one of those things, it's like, oh, okay, I need you to pull the details of this defect, including the repro steps. Oh, okay, I don't know how to do that yet. Well, go ahead and create a script for it and put it in that skill. And then I'm checking that into the repository, and now everybody on my team can do that.
Mm-hmm. Okay. So you mentioned a pre-code step for creating a plan. Do you leave it open like that, or do you favor one of the planning or specification formats that have come along?
Yeah, I actually started doing this markdown style of planning just before the GitHub
Spec kit?
Spec kit. Yeah, that's the GitHub one. Just before that was announced, and it was like, oh, that's the thing that I figured out too. I think a lot of people figured it out all at the same time. I already had I really just had two prompts /plan/implement. And so I tried out Spec Kit, and then it's like, I like the way that I do it better. So Spec Kit is somebody else's opinion. It's a good opinion, but I already have an opinion, so I'll use mine. And then OpenSpec comes out, and then BMAD comes out, and and it's like, there's a lot of these, but they're all somebody else's opinion, and I really like my opinion. So I have maintained my opinion over time, and I am now in the position that I think everybody should have their opinion on how their specification should work. For me, for example, mine are extremely mathematical. So I like to express everything in terms of equations. I like to describe the relationships. When I draw a diagram, it means something. That diagram, one to many, that's real. So I want my specifications to have that kind of weight. So yeah, I put into my my artifacts that this means that. This is the kind of reasoning that you should go through in order to prove that this is...
Now, diagrams. Do you draw diagrams, or do you have your tool draw diagrams?
Oh, I definitely have the tool draw the diagrams, yeah.
And what format do you find yourself favoring?
These days, it is Mermaid. In the past, I've been a really huge user of GraphViz. In fact, my book that you mentioned, The Art of Immutable Architecture, the diagrams in there are all GraphViz diagrams. And so when I do the kind of analysis that I do in that book, what I call historical modeling, for that I still use GraphViz. But for for a relational database, it's Mermaid.
Now, maybe you've cracked the code. I found that the rendering engine that Mermaid uses is nowhere near the quality that GraphViz is. Am I just missing something, or is that reality?
I think you're. Yeah, that's true. I think the important difference there, the reason that I go with GraphViz for ER diagrams, I'm sorry, Mermaid for ER diagrams, is that even though you can make a better looking diagram with GraphViz using records and tables and all that stuff, you put so much extra syntax around it, so much noise around the signal, that I think that and I don't really have a good measurement for this, but I think that the LLM has an easier time with the Mermaid, because the Mermaid reads more directly as the relationships that you're trying to express. And so, yeah, in the end, that's really the trade-off that I prefer.
Yeah. So you've talked about these skills and the plan and all that. It goes into the Git repository. So what it sounds like is you're coming up with these, but because it goes into the Git repository, it becomes team shared, right?
Mm-hmm. Yeah,
So
absolutely.
okay, so then it becomes a team asset, kind of like tests, kind of like build scripts.
Mhm.
So it seems like I find myself saying AI-driven development, AI-assisted development. There's more terms for, hey, using AI for development.
We can just call it vibe coding if you like.
Okay, since you opened that can of worms, in your opinion, what is the difference? What is the line between vibe coding and actually doing it well?
Yeah, I think the difference is what you care about. So even before AI, I've heard this argument, and it's always rubbed me the wrong way. The customer doesn't care how well the code is written. How many times have you heard that? And that was
Because they don't
even
look at the code.
before we started using AI. It's like, don't spend time on that. The customer doesn't care how well it's written. Well, the customer cares if it crashes. The customer
Right.
cares if it costs more to implement a feature 3 months from now than it does today. The customer cares if the product is slow. So there's a reason that we have the opinions that we have. We have these opinions because they keep the code more maintainable. We have these opinions because it keeps it more secure. It makes it more scalable. And so I think that applying our opinions to the code gets us a certain definition of quality. It's how we define what good is. And so if those things are within the wheelhouse of what you care about, then you will want to, if you don't have that taste and discernment yourself, you will want to partner with somebody who does. So you'll want somebody working on the code that actually does care about the quality of the code if you want to make sure it's secure and scalable and you're going to put it in front of a large number of users. If what you're after is the realization of an idea that now you can use yourself and maybe you can share with a few people, then there's absolutely nothing wrong with vibe coding. That is getting from idea to something tangible in a really short period of time. But yeah, you should know what the trade-off is. You should know that there's some expertise that people have earned over a long period of time. Maybe not everybody knows what that expertise is or could really articulate it or recognize it. But when you see a system that crashes all the time, or a website that takes 3 seconds to load the next page, then that's the manifestation of something missing.
Mm-hmm.
Some quality bar that's a bit too low.
Right. Well, as we close out here, you've used quite a few AI tools extensively. So what do you find yourself using the most? What are you giving to your teams? And then how much do you find yourself needing to budget per person in that usage?
Yeah. So 3 great questions. I personally found myself consolidating a bit more. I still subscribe to everything. I've got a Cursor license. I've got a GitHub Copilot license. But I'm starting to consolidate on Claude Code personally because I think that it kind of pushes you to the place that I want to be, where you care about the code, but you're not in the code. And so that's my personal position. For my teams, I know that the team that I'm leading right now is really starting to get comfortable with these things. And my client has chosen Cursor as the tool that they'll license for the teams. And I think that's a great choice for where they are, especially with where Cursor is starting to go. They are actually starting to go more in that Cloud Code direction. So it's like, okay, let the team grow with Cursor as it goes in that direction. And then at Improving, we are rolling out AI-assisted development to the entire organization. And for all of the developers, so we've got Windsurf licenses with the option that once you find that Windsurf isn't quite where you need to be, then let's move over to Cloud Code. So as far as budget, this probably is the hardest part of the conversation. When I talk to people about their own careers, I tell them they need to invest time and money into developing their own careers, which is a really hard thing to say when now some of those people are your direct reports. And it's like, yeah, but okay, so Improving is offering you this Windsurf license. Use that, learn with that. That's what we want you to do. But you know what? I really want to practice with Cursor. Okay, invest $20 a month in your own career and get a Cursor license. You're not going to be happy with the free tier. So I personally have budgeted, it sounds like a big figure to some people when I say this, $250 per month in AI. And so that's across all of the different subscriptions, development, as well as generating presentations. But I find that is a reasonable cost for the value that I'm getting. So everybody should decide what the cost is, and go ahead and make a budget and invest in your own career.
For software teams, like if someone wants to run the software team, so you mentioned a team being equipped with Cursor or Claude, is that what the expectation should be per person, or does it tend to be higher than that? What's the ballpark?
Yeah, I would say the ballpark should probably be a little bit higher than that. Yeah, this $250 per month that I'm talking about is really what I'm able to use nights and weekends.
Mm-hmm.
So if somebody's using this day after day, and they are at the more serious level, then I could easily see doubling that. But yeah, the value that you're getting out of that, it's just like don't even question it. That is peanuts compared to the value that they're producing.
What if it was $2,000 per person for using it all day? Would that be too high, or would that be still worth it?
Yeah, I would say, and these two numbers go up together. As the value that somebody is able to get from these tools increases, then the demand that they're going to be putting on the budget also increases. And so you should have a budget that you're comfortable with, and have that be adjustable per person, or at least to have different tiers. So yeah, we've at Improving identified a maturity model that we are using internally to talk about where are you on your AI adoption. So if you are just picking up Windsurf, and every time you prompt it, you get some code, and you're reading that code, and then you prompt it again and you get some more code, then we'll that's where we call a level 3 on our maturity model. If you're using ChatGPT and then copying and pasting, you're level 2. But then, yeah, as you start to develop your own skills and your own agents, you're starting to move into level 4 when you're starting to put those together in order to actually build out an entire software factory, to run an entire project, even a small team. You're starting to move into level 5. So the amount of value that you're getting out of the tools increases at each one of those values, and so the budget should increase as well, because the tools that you use at level 3 are not going to serve you at level 5.
Mm-hmm.
You definitely need to increase the availability of your tools as you climb that ladder.
Nice. Well, there is a lot that goes into this topic, but Michael, I want to thank you for coming and visiting with me on the AI DevOps podcast. It's a great talk. I appreciate it.
Yeah, thanks, Jeffrey. I appreciate it.
Happy to have you. And until next time, dear listener, keep shipping.
You've been listening to the AI DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and everywhere else. Visit our sponsor, ClearMeasure, at clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.